We now use differentials to approximate the volume of the shell given the thickness of shell equals zero point 0.2 centimeter. So here this one represents the sphere. We can use the volume formula for the sphere, which is given as volume V is given as 4 by 3 pi r cube. Now we differentiate to both sides with respect to r. So it gives dV over dr. This is the change in volume. This equals 4 by 3 pi is a constant. So I just write as it is. And then differentiate r cube with respect to r, which gives 3r squared when we use the power rule. Now we see that we can cancel this 3 and this 3 as well. And so this reduces to 4 pi r squared. Now we will multiply both sides with respect to dr. So therefore we get dv equals 4 pi r squared times dr. And this dr basically represents the thickness of the shell and dv represents the volume of the shell. So therefore this equals, we will plug in the radius which is given as 100 centimeter. So I plug in r equal 100 here, and then dr equals, this one basically represents the dr, which is the thickness of the shell, zero point 0.2. We plug in zero point 0.2 for dr, and so therefore this becomes when we, and this in fact is 100 square. When you multiply and simplify, we get 8000 pi. This is in centimeter cube because this represents a volume. This one dv is the thickness of the shell, and its decimal approximation is 25,132.74 centimeter cube. So therefore the approximate volume of the shell is either 8000 pi centimeter cube, or in terms of decimals it is 25,132.74 centimeter cube.